Hello and welcome everyone to today's Serverless Kubernetes Deep Dive. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to demo the new virtual nodes capability in Oracle Container Engine for Kubernetes. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out OKE for yourself. To access the promo, please sign up using the same email address that you registered with for today's event. We'll also be recording the session, and the link to the recording will be emailed to you in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called OKE New Features that you can access at the QR code here or at bit.ly/odevrel_Slack. Once you enter, you'll land in the general channel first, and from there you can search for the webinar channel. But we will also be checking the Zoom chat and the Zoom Q&A areas, and we will open up for live Q&A after the demo concludes. Today's webcast will be presented by Rishikesh Pal, Principal Product Manager, and Greg Verstraeten, Senior Principal Product Manager. So without further ado, I will hand it over to Rishikesh.
Hi, everyone. Welcome to this webinar. My name is Rishikesh. I'm part of the product management team at OCI. So let's take a quick look at the agenda for today's session. I'll start with a quick introduction to OKE and explain how it simplifies Kubernetes at scale. And then I'll turn it over to Greg, who'll talk about OKE Virtual Nodes and dive deeper into that feature to explain the serverless Kubernetes experience that we provide with it. He'll cover a demo. He'll talk about the seamless upgrade experience that you get with OKE Virtual Nodes. Then he'll cover some of the key use cases enabled by it. And then we'll also open up for the Q&A. So let's begin with introduction to Oracle Container Engine for Kubernetes. It is also commonly known as OKE. This is our managed Kubernetes offering in Oracle Cloud Infrastructure that simplifies how you run Kubernetes at scale. As many of you on this call know that Kubernetes has become the de facto standard of managing containerized applications in cloud and also on premises. So Kubernetes is a powerful tool for you to manage your containerized applications. However, the complexity of Kubernetes operations, particularly Kubernetes version upgrades, security patching, infrastructure management, all of these operational complexities make it difficult to adopt Kubernetes across organizations. And that's exactly what OKE solves. It simplifies the overall Kubernetes operational experience for you. So OKE is managed Kubernetes service that is built on the open source Kubernetes. It is fully compatible with upstream open source Kubernetes. In fact, it is CNCF certified Kubernetes conformant, which means there is no vendor lock-in. You can move your workloads from other Kubernetes environments to OCI without having to make any changes. It provides built-in management. It provides a fully managed control plane for Kubernetes clusters. And for data planes, you have flexibility to choose between managed nodes, where you get more control over the underlying node infrastructure, or you can choose the new OKE Virtual Nodes capability that delivers a fully serverless Kubernetes experience. One of the key differentiators for OKE is the superior price performance that it provides. It's built on OCI's next generation flexible compute infrastructure that provides at least 3 times better price performance compared to other cloud providers. So you really get value for, you can really optimize the cost of running Kubernetes with OKE. In terms of reliability, OKE provides highly available control planes by default. You don't have to configure anything. And now we also provide financially backed SLAs with OKE. Security is one of the key pillars for all the services within OCI. And even for OKE, we provide advanced security features built in without any additional cost. So you can leverage features such as private clusters, encryptions out of the box, and you can easily configure them. In terms of deployment flexibility, OKE supports a number of compute shapes such as ARM, x86, GPU, and more. You can create heterogeneous OKE clusters and combine different types of shapes in the same cluster. For example, you can create a cluster with ARM node pool as well as x86 node pool and deploy your Kubernetes workloads based on the requirements on the right compute shape. Since OKE is built on open source, you can easily extend the Kubernetes capabilities, leveraging some of the open source operators that we provide for things like Oracle databases or other OCI services, or you can bring your other open source tooling and operators and run them on your Kubernetes clusters. Last month, we've done a major release of OKE where we've added a bunch of new features which further simplify the Kubernetes operations experience at scale. We've added a new capability called OKE Virtual Nodes for serverless Kubernetes, and Greg will talk more about it. We've also added a feature called add-on lifecycle management that simplifies installation and configuration of Kubernetes cluster add-ons. With this feature, we provide a set of Oracle managed add-ons. These add-ons include essential cluster software like core DNS, CNI, and so on, as well as optional software that you can install, such as database operators or WebLogic operators. With this new feature, Oracle manages these add-ons and you get control over which add-ons to enable, which versions you want to install, and you can even opt in or opt out of the automated updates. We've further enhanced the security with the new features. OKE Virtual Nodes in particular provide strong workload isolation. We've also added a new workload identity feature, which makes it easy for you to configure IAM policies at the pod level to provide granular access control to pods for accessing other OCI resources and services. So this further improves the security posture of your workloads running in Kubernetes. So to summarize, with the new features that we've added and overall the managed Kubernetes experience that we provide with OKE, you can significantly lower the total cost of operation, leveraging the superior price performance of compute and the serverless Kubernetes experience that Greg will talk about, which reduces the overall time, cost, and effort required to run Kubernetes at scale. You can offload some of the management complexities to the OKE service. You can accelerate adoption of Kubernetes in your organization, leveraging OKE and ensure optimal operations with less risk. You can improve agility of delivering applications without compromising flexibility in terms of control over underlying CPU architecture, resource allocation, and even topology spread for distributing your workloads across different availability domains. And you can improve productivity of your development teams and further shorten the time to market to deliver applications at scale on Kubernetes. So with that introduction to OKE, I'll now turn it to Greg to dive deeper into OKE Virtual Nodes.
Thanks, Rishi. All right. So the traditional way to consume Kubernetes is to create a cluster that is made of the control plane. And with OKE, you have a fully managed control plane, meaning that you provision your cluster, the control plane comes up, and the control plane, it's OKE service team responsibility to scale it, provision it, scale it, and fix it if something some problem comes up. As a user of OKE, you don't have to do anything in regards to the control plane. And the traditional way to assign resources to the data plane of the cluster is to provision some nodes that are either bare metal instances or virtual machines, and OKE provides the API to manage the lifecycle of those nodes. But it's your responsibility to pick the right number of nodes that you want to run, that you want to have in your cluster to execute your applications. It's your responsibility to size them and upgrade them on time using the OKE API. Some customers feedback, we got the feedback from some customers that those activities related to the data plane represent quite a big task. It takes some time away from the engineers, and the reason is right sizing the data plane is a difficult activity. They often have to configure the cluster autoscaler because the workload resource requirement goes up and down during the day, during a month. The upgrade of the data plane requires the collaboration of multiple teams because a single cluster is running applications from managed by different teams. So they have to plan for a window of maintenance and have multiple teams collaborate to upgrade the cluster and make sure that the application come back on time. So those customers asked us for a different way to run the application, but still with Kubernetes. And in response to this requirement, we came up with virtual nodes. So virtual nodes provides you with a serverless Kubernetes experience, meaning that you consume the Kubernetes API of your cluster, and that's how you deploy and manage your applications. But it's serverless because you have no infrastructure to manage. All the VMs, all the compute resources is provided to execute your applications without having you to be involved in choosing a number of VMs and a number of CPU for your VMs. You don't have to manage the infrastructure. Resource scaling is made easy. You don't have to manage a pool of resources in your cluster data plane. This is provided for you for the needs of your applications. Upgrades are made seamless. You don't have to cycle nodes in your data plane to replace them to pick up a new Kubernetes version. The upgrades are synchronized with the cluster upgrade, and you have minimum impact on your applications. And we do this without taking away the control and the flexibility to run your application requirements. So for example, you still control the processor shape that is used to execute your applications. We know that some applications work better on Intel processors, some others are more on AMD. Some application might run perfectly on ARM, and it's you can realize the cost optimization of using ARM processors. And some of our competitors took the serverless Kubernetes, provide the serverless Kubernetes experience, but they take away the way you can ping applications on nodes or spread the application, the pods that execute the application across availability domain and fault domain. This is not the case with virtual nodes. Virtual node is an abstraction to real Kubernetes worker nodes. And so all the Kubernetes constructs like node affinity and tie affinity, topology spread constraints are available. And so you can schedule the pods for your application across availability domains and fault domains. You can have them on the same nodes or on different nodes. You have full control over that. Virtual nodes enhance the security that you can bring to your application. It is now possible to run SaaS application, multi-tenant application on Kubernetes, untrusted workload on Kubernetes. And the reason is with virtual nodes, each pod has its strong VM-like isolation. It's like every pod is running in its own VM. So it's very hard to get out of the pod. You have like a VM surrounding. And on top of this, you benefit from the VCN. VCN is virtual cloud network. The security that it provides. Each pod has its own dedicated VNet that connects to a subnet of your VCN, and so you control the security rules that to allow the traffic to and from your pods. You can inspect the traffic using flow logs. So again, it contributes to an enhanced security for your applications running on virtual. And finally, virtual nodes allow you to optimize your costs. You don't pay for nodes. This is not the pricing model for virtual nodes. You pay per pods, and you pay for your pods at the compute price. Meaning there's no premium to run your pods. It is exactly the same price to run pods with virtual nodes as running pods on a regular nodes at the core level. So one core used for pods is at exactly the same rate at the same price as a core for VM. There's no premium. And in addition, you have a small a small charge for each virtual node, but it's very nominal. It's like 1.5 cents an hour. So on this chart here, you see OKE working with managed nodes, where you have the cluster control plane running in the OKE service tenancy. So you just consume the API server from the control plane. You don't have any actual VM for the control plane running in your tenancy. And then for the data plane of your cluster, you have compute instances that we call managed nodes, and they run in a pool of managed nodes. And that runs in your tenancy. You have to size them. You have to upgrade them on time, and in exchange, you have control over the configuration of those nodes. You of course, the OKE API provision the nodes for you, but you can tweak the configuration of the operating system, add some software to it, and then when you deploy your application, you have access to those applications running on those nodes. So that's OKE with managed nodes that has been available for some time, and we keep on improving them, making the management of those nodes more and more easy. Now, OKE with virtual nodes is we bring all the resources in the OKE service tenancy. Meaning that you have the cluster control plane running in the OKE service tenancy, but also the virtual nodes themselves and the pods and the resources that execute your pods. All of this is running in your OKE service tenancy. What you have in your tenancy is your VCN. That's you control the configuration of your VCN, and the VNIC for each one of your pods is plugged into a subnet of your VCN. And so when you create a service, a Kubernetes service of type load balancer, you have a load balancer that is created in your tenancy, and it load balance the traffic across the VNICs of the pods. So the data plane operation are greatly reduced with virtual nodes. You don't have to manage the capacity. You're not involved in any node repair or misconfiguration. You don't have to patch the operating system. The OKE service tenancy, the OKE service team is doing all this for you. And finally, for the upgrades, we have a way to upgrade the cluster that is synchronized with the cluster control plane, and it makes the upgrade seamless for you. But I'll get back to this. And so by taking all those data plane operations, we know that it saves some time from your engineering team. And we've seen customers like saving several hours of engineering time by and let them refocus on what is important. So how do you manage the capacity of the cluster data plane? What it might sound a little bit magic what I'm explaining so far. So with managed nodes, you know how it goes, right? You have the control plane, and then you create node pools, and that is part of your cluster data planes. And the node pools are made of multiple compute instances. It can be VM, it can be bare metal servers, and you assign each one of those nodes in the node pool have a number of CPU and an amount of memory that is set, right? So when you create your node pool, you say, all right, I want, for example, 3 nodes, and those 3 nodes will have two cores and 8 GB of memory, for example, right? You define those resources when you create the node pool. And when you need more, halfway through at 8 a.m. on a Monday, everybody is logging in. You need more resources at that time. You have to scale up the number of nodes in your node pool. You do that either manually by adding nodes, and then when the load is gone, you reduce the number of nodes, or you do it automatically using the cluster autoscaler. The cluster autoscaler looks at the resources that is being consumed in a node pool, and choose to increase or decrease the number of nodes in the node pool. We got the feedback that configuring the cluster autoscaler is not necessarily easy, and it's not easy to get the resources right on time. So with virtual nodes, it's a different approach. You have the same cluster control plane, and you create a node pool made of virtual nodes. And so same thing. You can say, all right, I want 3 virtual nodes in my virtual node pool. What's different here is that you don't specify a number of CPU and memory. You define a shape, which is but more the processor type. So you would say, all right, I want AMD E3 or E4. In the future, will support Intel and ARM. But that's you just define a processor type here. And then when you start scheduling pods by doing a deployment through the Kubernetes API, you have the CPU and memory request as part of your pod description, pod spec, and that's what we use to create to assign the right amount of resources to your pods. So let's say you do I want 1 core for each one vCPU for this for for the pods of the deployment I'm doing, and I want 1 gig of memory for each one of those pods as part of your YAML file for the deployment. That's what we use to right size the amount of resources needed for each pod. And when you don't specify it, when it's a best practice, it's a Kubernetes best practice to specify the right amount of resources that each pod need. But if you don't do it, we use a default that is 1/8 of the core. So you see that there's not a correlation between the virtual nodes and the resources that the pods will need. So you're not involved into the sizing of the virtual nodes. The resources assignment comes when you do the deployments. So I'd like to take a break and show a demo of the creation of the virtual nodes in the cluster creation, and that is made of virtual nodes, and then the deployment of a workload. So first, we're going to create a cluster with virtual nodes. So I'm on the OCI console, and I use the quick create workflow to create my cluster. And so here you have two types of nodes. You have managed nodes, and that's what I explained. It's like the traditional way to configure the data plane of a cluster with nodes. And as nodes, you have virtual machines or bare metal servers. And the alternative is virtual. And so with virtuals, you have no VMs, right, to manage or provision. But we provide an abstraction for Kubernetes over real nodes. And so you saw that when we click virtual node, a lot of information are not necessary. Basically, we just have to provide the number of virtual nodes. And so here we choose 3. 3 is good because we are going to spread across availability domain or fault domains. And then we provide a shape for the pods, which is really the processor type. Right? And so we get a summary of what will be created. So there's a VCN that is created as part of the cluster creation, and then the cluster is creating along with the virtual node pool. And so we have 3 virtual nodes here, and those nodes don't run in your tenancy. They're just resources with an IP address. Kubernetes sees them as active and can start scheduling pods onto those nodes. So now we're going to deploy an application. So virtual nodes don't break the compatibility with the tools that you're using today. You use the same kubectl commands. You use the same Helm CLI to deploy your applications on virtual nodes. We don't break the Kubernetes compatibility. So here we deploy a Helm chart for an e-commerce application. That's an e-commerce application that we build for demo purposes. It is made of multiple services, of microservices, and so I'm going to list the pods that we have initially. And so I think we have 6 of those pods, and so there's a service that is created as part of it, and that's for the edge microservice, and this is the application that is served by this microservice. So now I'm on the Kubernetes dashboard, and we're going to, in parallel of this, we generate a workload. So we're going to increase the workload of users to simulate an activity. So we deploy the application, and users are coming, and they start putting products in their cart and buy those products. It's the number of HP horizontal pod autoscaler. The Kubernetes construct is active and is configured to scale the number of pods when the activity is coming. When the pods are working, HPA is configured to increase the number of pods automatically. And so where are the resources going to come? Well, with virtual nodes, you don't have to worry about, do my nodes have enough capacity for the increased number of pods? This is not the concern with virtual nodes. Pods can be created and scheduled on virtual nodes with the impression that there's unlimited resources to assign to those pods. So that's what's going to happen now. We are going to see Mushop autoscale, and it's really sitting back and seeing the pods getting created. We're already at 333 pods, and virtual nodes provide all the resources that are necessary to execute those pods. No time I had to go to my node pool and increase the number of nodes. It's not necessary because virtual nodes provide all the resources that the pods need. Okay, I'm going back to the slide, and now I'm going to talk about upgrades. So Kubernetes upgrades are is something that in general is complicated, because in a traditional way to do an upgrade, you have to cycle the nodes of your cluster data plane. Control plane is easy with with managed Kubernetes offerings, because we take care of the replacing the nodes, and you don't have any impact on your workloads. However, the data plane, traditionally, when you use nodes that are compute instances, you have to cycle them. So you replace them one by one. And so that has an impact on the workloads, and you have to make sure that they restart well. With virtual nodes, we simplify those upgrades and provide you with a seamless Kubernetes upgrades. So the first step is the upgrade of your cluster control plane. And it happens asynchronously without any impact to your workloads. That's something that you already have today with managed nodes. And then the step two, once this is done, we upgrade each virtual nodes in place. So again, there's no impact to your workloads. We take the virtual nodes and we upgrade those virtual nodes. They don't change. They stay the same. And then kubeproxy with virtual nodes, kubeproxy, which is a Kubernetes component that establishes the communication with your pods. Kubeproxy with managed node usually run on the worker node itself, but with virtual nodes, mini kubeproxy runs on each one of the pods. So depending on the Kubernetes version, kubeproxy has to be upgraded on the pods. And so for this reason, we have to evict the pod and have it reschedule onto the same virtual nodes. And this has a minimal impact on your workload activity, because we respect the pod destruction budget. So meaning that we take each pod and reschedule it to go on the same virtual nodes, And if you define a pod disruption budget that tells Kubernetes, hey, at any point in time, this application needs at least 2 pods or 5 pods, depending on your needs. And so the upgrade process will make sure that this is respected at any point in time. For the application, there are 2 pods or 5 pods running to serve the user activity. This seamless upgrade is going to change the life of engineers during the upgrade process of the clusters. Our customers are very excited about taking advantage of this feature to make the upgrade process as easy as possible, and making it on time. We notice that our customers are lagging to pick up some Kubernetes upgrades because it's such an involved process that it's never the right time. With seamless Kubernetes upgrades, it will help them stay current on the latest Kubernetes upgrade. On the latest Kubernetes version. So, what can you run on virtual nodes? Well, so the direction that we're taking is that any Kubernetes workload should be able to run on virtual nodes. Now, we just released virtual nodes, and it doesn't yet support all the Kubernetes objects that you need to run, for example, a stateful application. So currently, you can only run stateless application on virtual nodes, and your states. When I say stateless, the state has to be outside of the Kubernetes cluster in a database, for example. But in the future, we'll support persistent volumes, and you will be able to run stateful applications, or you will be able to run data processing onto virtual nodes, which will be great because data processing pipeline, the resources go up and down quickly, right? I mean. You don't need the same amount of resources at any point in time because the processing of data requires a lot of CPU and memory power at one point, and then once the job is over, it's better to release those resources. With virtual nodes, it's going to be done automatically. It's ideal to run jobs, batch workload because they're characterized by a lot of processing power that is needed at one point in time, and then you release it. So from an operational point of view, whenever you need elasticity, when you have a spiky workloads, virtual nodes are the best choice. You can run Kubernetes without being involved in the sizing of your pool, and with a very simplified process to upgrade your Kubernetes clusters, and including the data plane. And virtual nodes open the door to new type of workloads, like, for example, multi-tenant, untrusted workloads, SaaS application with multi-tenancy. This is possible on virtual nodes because each pod is strongly isolated from each other. And finally, from a cost point of view, you pay the model with virtual nodes is to pay per pods, right? In contrast, managed nodes you pay for nodes. With virtual nodes you pay for pods, and your applications are made of multiple pods, right? So it simplifies the application level chargeback each application is made of multiple pods, so it's very easy to look at your resource consumption and say, all right, this application took that much of resources at the end of the month. All right, and so now in OCI, you might say, all right, I've got multiple services to run my applications. What's the best service to run my application? So on this slide, the intent is to help you figure out what to do, which service to consume to run your applications. So you have OCI Compute. OCI Compute, you have the most control over your workload, over the server itself, right? You control the operating system and so it can be used for anything. But at the same time, you have more responsibility into the management and the operations and the configuration of the operating system. So it takes more. You're more involved in the operations of those resources. And then you might have your application that is already containerized. And so when your application is containerized, meaning that you have a container image to execute your application, that opens the door to Kubernetes and OCI container instances. With Kubernetes, you have a standard platform to operate containers at scale. It comes with its complexity. Kubernetes requires some skills from the engineering teams to be able to configure their application to run at scale. And so in Kubernetes, you can use either managed nodes if you need the control over the node configuration and how the resources are assigned to your applications. But you have access to GPU. You can run stateful workloads. If you want less operations and less involved into the assignment of resources, you can use virtual nodes, and that's what we described in this session. You benefit from a per pod pricing. Currently, you cannot run GPU, you cannot run persistent storage, but that is coming. That is on the roadmap, and it's ideal for spiky workloads, workloads that which resources go up and down quickly. And then you might have teams that don't know Kubernetes, and they just want to operate applications without knowing Kubernetes. And for those teams, container instances, and that's what this service is made for. They deploy, all they need to do is to have a container image that they deploy in OCI with container instances. It is simple, it is secure, and the price to execute a container, there's no premium. It's exactly the same price as using OCI Compute. So if you have a container and you want to execute it in OCI, you don't have Kubernetes skills, container instances is the right choice. And finally, if you have code that you want to execute based on an event, then OCI serverless functions is the right choice. You might use it to implement a simple API to react to an event within your cloud tenancy. OCI functions makes it very easy to execute some code based on an event. You might want to learn more about what we discussed today. So you have links on this page, the OKE Resource Center, where you have access to managed nodes, virtual nodes, information, all the customers that are running with OKE today. Great inform. That's the centerpiece of information on OKE. And then we wrote a couple of blogs about all those topics, about virtual nodes, about the OKE in general, and all the latest features that we delivered lately, and finally the documentation about virtual nodes.
Thank you so much for joining us, and we hope to see you again.
Thank you.